The recent activity on the San Andreas Fault has sent shockwaves worldwide, leaving scientists both amazed and concerned. This infamous fault line has been the subject of constant study for years. In this video, we will explore the latest developments and what they could mean for millions living in the danger zone. Stay tuned until the end to learn more. The San Andreas Fault is often associated with the next major earthquake. It formed around 30 million years ago when the North American plate consumed almost all of the Farallon plate. Since then, the North American plate has collided with the Pacific plate along a strike-slip fault, one of the world's most considerable faults, stretching over 800 miles from the Salton Sea to Cape Mendocino. The responsibility divides the state in half, with the Pacific plate, including San Diego, Los Angeles, and Big Sur, and the North American plate, including San Francisco, Sacramento, and the Sierra Nevada. Hundreds of active and passive earthquake faults connect the two plates. A San Andreas earthquake is a strike-slip event that occurs along the edges of tectonic plates as they slide past one another. This type of fault is a vertical crack in the Earth's crust that causes horizontal motion along the fault line. The rock walls move to the left or right relative to one another. Horizontal compression causes the formation of these faults. The San Andreas Fault runs deep near and beneath some of California's most densely populated areas. It passes through desert hot springs, San Bernardino, Redwood, Palmdale, Gorman, Frazier Park, Daly City, Point Reyes Station, and Bodega Bay. The southern San Andreas Fault runs through Los Angeles County, cutting through the San Gabriel Mountains on the north side. It can potentially create severe earthquakes of up to magnitude 8, affecting densely populated areas in Southern California. A recent study of rocks excavated nearly 2 miles below the surface reveals that the core part of the fault has experienced numerous significant earthquakes, some of which may have been relatively recent. The research, which uses novel chemical analysis methods to estimate the heating of rocks during prehistoric earthquakes, was just published in the online edition of the journal Geology. This means that the central section of the fault could have more significant earthquakes than previously thought. The San Andreas Fault poses numerous dangers. The northern part was the site of the devastating 1906 San Francisco earthquake, which killed 3,000 people and devastated much of the city. The fault was also responsible for the 1989 M6.9 Loma Prieta earthquake, which killed over 60 people and destroyed a major elevated roadway. The southern part was responsible for the 1994 M6.7 Northridge earthquake, which caused extensive damage in the Los Angeles area. Many scientists believe that the Northridge earthquake near Los Angeles, which killed around 60 people, is storing energy for an event on the scale of the 1906 earthquake. However, the middle part of the San Andreas Fault is relatively harmless, with only one location towards its southern end known to create earthquakes of magnitude 6. While not particularly dangerous by normal standards, these events occur every 20 years or so. Scientists have established a huge observatory atop the fault near Parkfield to examine indications that may indicate an impending earthquake. The observatory includes a 3.2-kilometer deep borehole from which rock cores were extracted and monitoring sensors both above and below ground. When earthquake faults move, friction along the moving sections can cause temperatures to rise hundreds of degrees higher than the surrounding rocks. This heats the stones, modifying the organic compound content of any sedimentary strata along the fault route. Researchers Pulsar and Heather Savage recently discovered how to use these so-called biomarkers to pinpoint prehistoric earthquakes. They found many such changed compositions in a highly disturbed sedimentary rock stretch between 3192 and 3196 meters below the surface. The latest study claimed that the blackish, crumbly material has evidence of more than 100 earthquakes. In most cases, the fault appeared to have leaped more than 1.5 meters, implying a magnitude 6.9 earthquake, similar to the disastrous Loma Prieta and Northridge catastrophes. However, many of the earthquakes may have been larger, according to the researchers. The current official California earthquake hazard model, which sets building regulations and insurance rates, allows for a significant central section rupture. However, given the lack of evidence for any such preceding occurrence, including this possibility arrived at by mathematical calculations, was controversial. The current study looks to be the first to show that such earthquakes have happened in the area. According to the authors, they may have started in the middle section or, more likely, begun to the north or south and migrated through the central unit. The trenches dug by paleoseismologists over the core area did not reveal any disturbed soil layers, suggesting surface earthquakes in the last 2,000 years, which is the limit of detection using that method in this location. However, the excavations may have missed many earthquakes that did not necessarily shatter the surface in specific areas. To answer this question, the researchers developed a novel technique. Biomarkers found in thin bands. The team analyzed sediments produced tens of millions of years ago in an ancient Pacific basin subducted beneath California. The potassium-argon clock revealed that the ages of rocks surrounding the thin quake slide zones were as young as 3.2 million years, indicating the possibility of more significant earthquakes in central California. The study is groundbreaking as the creeping section is difficult in paleoseismology because the creep quickly erases earthquake evidence. If this holds up, it is the first sign of a significant seismic rupture in this part of the fault. This suggests that a large earthquake could start at the southern tip of the San Andreas and continue up to the end of the northern section, known as the Big One. This is all for today. Hope you enjoyed the video. So like it and share the video with your loved ones. And never forget to subscribe to the channel and hit the bell icon for more updates.